Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Welcome friends to the 7th lecture where we are going to talk about basics of fire engineering. Now let us enter into the domain of understanding fire as an engineering process. We will talk about fire chemistry more in detail to understand the consequences of fire. Then slowly we will move on to structural fire engineering where Professor Gaurav will add his values of contribution to explain how the fire calculations on fire loads are estimated on structural members and how to design them for a variety of such loads. So welcome to the 7th lecture on fire basics, which is a sequel lecture, lecture number 1 on fire basics. Friends, fire is a complex process. Fire is a complex chemical process which involves rapid oxidation, it releases many constituents like heat, light, and combustion gases. All are equally dangerous and bad for structural design of maritime structures. This reaction, known as combustion, has got three fundamental components. The three fundamental components are fuel, oxygen and heat. When you interconnect all the three as three arms, then we call that as a fire triangle. Okay? So, let us pay attention to some of the important textbooks and references cited at this moment for this lecture onwards. Please pay attention to a few of them and try to procure them for institute library as well as a self reference copy, so it becomes useful for you to follow these lectures thoroughly. Talk about fire characteristics more in detail. We said that the chemical reaction, which is the combustion process, and fire is visible effect of the process of combustion. It occurs between oxygen in air and fuel. Now, the fuel can be of three categories: solid, liquid or gases. The reaction will keep going as long as there is enough heat, fuel and oxygen. Therefore, the heat, fuel and oxygen is called as a fire triangle. In simple terms, if you add oxygen to fuel, it releases carbon dioxide and steam and heat energy. The combustion of hydrocarbons are highly vulnerable. Hydrocarbons acting as fuel are compounds that contain only carbon and hydrogen. For example, look at methane. It contains carbon and hydrogen. Okay? So, now the question comes, if these components are removed, let us say take a fire triangle. In a fire triangle, if one of the arms is deleted, in fact I should say is depleted. So, it has got fuel, oxygen and heat. Okay, you control any one of them, right. So, generally people used to control fuel. Fuel supply is stopped or fuel supply is exhausted, etc. Sometimes by sprinklers, by water bodies or by making it cool, heat is also compromised. If any one of the arm is deleted or depleted, you will see you can control fire accidents. And the effect caused by fire can be mitigated. Okay. So, let us say why I should need fire load to be assessed. Before that, let us try to ask a question. If fire triangle does not fully explain fire, then one can also start learning fire science using tetrahedron fire. This has got 4 components. The components are heat, oxygen, fuel in the presence of chain reaction between them. So, this 4th component makes it as tetrahedron and fire process can be easily understood making this. So, fire therefore friends is a chain of chemical reactions. Once fire starts, the breaking down of fuel molecules releases free radicals, highly reactive atoms or molecules that contain or continue to react with oxygen. These chain reactions generate additional heat, further breaking down more fuel and creating self-sustaining process. So, it is very important to know that once fire breaks out, it continues to remain as self-sustaining process. That is very important. That is how fire outbreaks continue for a longer time. The common example illustrating both models is a candle flame. One can look at a candle flame to understand both the fire triangle and fire tetrahedron model. The wax in this case acts as a fuel. Okay. Of course, oxygen is drawn from the environment and you need an initial ignition source. Which is set by a matchstick. So, that supplies heat. So, the fire triangle is complete. Okay. Now, once the wax melts, it vaporizes. It reacts with oxygen to maintain the flame. The fire tetrahedron now comes into play. When the heat generated by the combustion process keeps on vaporizing more wax. So, more wax is vaporized, more heat is generated and more fire is happening. So, that is a very interesting concept. So, in this whole process, if any one element, for example, the fuel which is wax or the oxygen which is coming from air or the heat which is coming from the flame is put out, you will see that the chain reaction stops and the candle extinguishes. Okay, it is a very interesting and simple example to understand fire triangle and fire tetrahedron action. Now, let us understand why I must assess fire load in structural design. As we saw, steel is one of the favorite construction material for industrial structures and maritime structures. Design procedures under conventional loads like dead load, live load, wind load and environmental loads like wave, current, earthquake, etc. are well discussed in the literature, but special attention is required. You want to design them for fire, blast and impact loads. Maritime structures are more susceptible to accidental explosions. Although such accidents are rare in frequency of occurrence, the consequences caused by the accidents are very high. Therefore, they have a very high risk, because risk is actually a product of frequency of occurrence multiplied by the consequences. In both cases, the financial and personal loss is very high. Therefore, it causes serious impact on public and environment. Therefore, friends, fire load assessment on any maritime structure is mandatory, though you may not design it for fire resistant design. Let us now try to understand the difference between fire and explosion. Before doing that, let us see what are the stages where fire grows. So, let us say There are 3 stages. As the fire grows. The fire growth. The first stage is the ignition stage. When the fuel encounters sufficient heat, it ignites. Okay. The initial heat raises the temperature. Raises the temperature of the fuel to its ignition point, and that will cause combustion reaction to start. For instance, if you strike a match against its box, producing frictional heat that ignites the matchstick, at this initial stage, extinguishers or immediate suppression methods are very effective. The second stage of fire is the growth phase. During this phase, fire spreads rapidly. Several heat transfer mechanisms happen here. Occur here. Okay. Conduction, convection, and radiation all happen here in the growth phase. For example, consider a room where a furniture is burning. Okay, the flame initially heats the surrounding air through convection. So, the surrounding air is heated through convection. The air rises and spread upwards. As it spreads upwards, it starts further heating other elements in the room. Okay. Furthermore, radiation also spreads heat directly to other materials. So, when other material is heated, the fire intensity now increases. In this phase, there is a rapid intervention of water sprinklers, hose reels, or fire suppression systems to put out the fire. If there is enough fuel available, then fire continues to grow. Now it enters something called fully developed burning phase. Here the fire achieves its maximum intensity, which is characterized by high temperature and extensive flame spread. In this phase, flames engulf much of the available combustion material, creating hazardous conditions and significantly endanger structural integrity. The last stage, which is the declining stage, is the decay phase. In the decay phase, the fuel supply diminishes, as a result the oxygen level decreases. So, consequently, fire intensity and heat output decreases, and fire extinguishes. Okay? So, then in that case the fire extinguishes significantly. Let us try to plot this in a single case as you see on the screen here. Let us try to plot all the stages, different stages of fire. Fire development. So, let us say this is time, this is temperature. So, this is also called as time temperature curve. Okay. Now, let us mark these phases by different lines. Let us say the natural fire curve starts from here, it reaches here and goes here and then comes. So, this is ignition stage and this is the growth stage, this is the burning stage and then the rapid stage or the decay stage. So, this is the natural fire curve. You will notice that at the, you can say, modify this figure slightly. At the burning stage, the temperature reached is maximum. Okay? Whereas, for structural design, we start this curve from the growth stage. Making this curve can also be modified slightly like this. Okay, let us modify. So, at the growth stage, the fire starts, touches here, and then this is my standard fire curve. So, the ignition stage in standard fire curve is ignored, it starts only from the growth stage. Okay. This period where the fire grows is called flashover. Okay. Having said this, now let us try to understand the difference between fire and explosion. Fire is a rapid exothermal, it gives away heat, exothermal oxidation of an ignition fuel. Fuel can be either solid, liquid or gaseous states. Fire releases energy, it is exothermal oxidation in the form of exothermal reaction. With passage of time, the released energy reaches its peak intensity. Fire can also result from an explosion, which is a rapid expansion of gases caused by pressure or shock waves. Shock waves propagate very fast and results in adiabatic expansion. Look at explosion. Explosion can also result from fire. It can be either mechanical or chemical process. About 70% of accidents occurred in offshore and maritime industries are due to hydrocarbon explosion of fire, for which the consequences are very serious. If the process plant deals with LNG, then the potential risk involved due to fire and explosion is furthermore, because the physical and chemical conditions of LNG are different from liquid hydrocarbon. Okay. So, then why fire accidents actually occur. Leaks or smoke in heat energy systems lead to fire. They should be periodically inspected and maintained properly. In case of smoke, one should not disconnect the smoldering insulation, as this will allow excess air inside and cause auto ignition. One should not also let the fluid drop on any of the heat sources, because if this is happening, this will ignite the fluid. If fluid leaks and gets trapped within a system, it can get oxidized, which can also result in exothermal reaction. Let us see how fire is categorized. Fire is categorized in 4 ways: no risk, low, medium and high risk fire. No risk refers to when module has no energy to cause fire. Low risk fire occurs when module stores non-flammable material and equipments. Medium risk fire occurs when module contains electric power units and major technical equipments. High risk fire occurs when the module contains hydrocarbon, chemicals and flammable liquids, chemicals and gases. So, category of fire is placed under 4 verticals. Fire can also be classified based on fuel as class A, B, C and D. Class A refers to fire that occurs from wood, paper, cloth and trash, non-metallic components. Class B refers to fire occurring from flammable gases, oil and chemicals. Class C refers to fire breaking out from energized electric equipment, may be fully charged or connected to live power. Class D is a fire breaking from metals, sodium, potassium, aluminum, magnesium. Then one question is, why I have to classify fire? If I know the classification of fire based on the fuel which is causing fire, I can always choose the extinguisher to control fire. So, firefighting equipment to control different classification of fire has extinguishers of a different nature. So, extinguishers also classified based upon what classification of fire has occurred. So, generally in maritime industries and offshore plants, we generally have fire caused from class B, class C, sometimes class D as well. Okay, usually they are B and C class fire. Classification of fire can also happen based on burning. If fire is triggered when leakage or spill of any flammable liquid occurs, then it can be continued to release energy. So, it can be then classified as pool fire, jet fire, fireball, flash fire. Furthermore, there is a sub classification of fire called as flares, fire on sea surface, running liquid fire. This sub classification can be further grouped into flares can be treated as jet fire, and fire on water surface and running liquid can be treated as pool fire. So, this further refers to jet fire and pool fire automatically. So, friends, fire can be categorized based upon what material causes fire, what fuel causes fire classification. Furthermore, they also depends upon how they burn. Pool fire, jet fire, fireballs, flash fire, we will see them in detail in the later part of the lecture. So, fire classification is very detailed and elaborate. Let us talk about what is a pool fire. Pool fire occurs when liquid is released on a surface or when a liquid spills on a surface. It is very common. You have a tank where LNG is stored. Because of some crack on the tank, or they may lost the connection, or because of extensive heat and vaporization, this liquid can get released or spilled over on the surface, and that can cause fire. That is called pool fire. When liquid spills over a surface, it forms a pool. It vaporizes and causes fire. It burns with a little momentum It is a turbulent diffusion fire which burns above the pool that vaporizes hydrocarbon. It has got a very high probability in offshore platforms and oil storage reservoirs or tankers. You must have seen many industrial structures store oil or LNG on the storage units. Pool fire may also occur due to rupture of pipelines because of cracks on storage tanks, and these cracks can be result of corrosion failure on metals. Pool fire of course diffuses with time. When the fuel evaporates or vaporizes completely. Pool fire generally occurs in open environment, therefore they are well ventilated, and hence these fires are fuel controlled fire. As long as fuel exists, this fire will grow. Once the fuel extinguishes, this fire will stop. Let us talk about how to design a maritime unit or a structural unit under pool fire. What we generally do is use foams to extinguish pool fire. So, we create barriers between gaseous fumes and air. It prevents mixing of fuel and oxygen and thus extinguishes fire. Small dikes are also constructed. You must have seen in storage cans or tanks where LNG or even fuel is stored. You will notice that a small bund is created all around the tank. Okay. In plan, all around the tank you have a bund. This is the tank and this is the bund. Okay. I can even remove this part, it is okay, not necessary. Usually this bund is of height about 300 to 500 mm. If this diameter is capital D and if this height is capital H, usually this spread is not more than 30% of H, okay, 1/3 of H, not more than that. So, you create a circumferential bund all around the tank and pool fire actually falls and spills over this area, and the fire is controlled within this segment. Suppose if you have tanks, the adjacent one, there is a bund here. So, this fire is controlled within this segment and vice versa. Okay. So, small dikes are constructed all around the tanks to control the spread of pool. Firefighting jets are provided on these decks to control fire. So, these decks or dikes will have extinguishers. So, whenever there is a fire, you will notice that these extinguishers will pour water. Okay. They will control the fire. So, they have extinguishers provided all on the dike sides, they will control the spread of fire. Dikes are constructed to control the spread of fire, they are constructed all around the tanks. While diameter of the dike and pool are same, height of the dike is about 1/4 of its diameter. These are some dimensional restrictions we have. Suppose we want to find what is the length of pool fire, I can use this empirical equation where if you know the pool diameter, if you know the heat release rate and the density of air, you can always find the length of pool fire, how long the pool fire can spread if you know the diameter of the pool. Okay. It is a very simple equation where dP stands for diameter of the pool and this density of air, heat release rate of the chemical which is stored inside is known. I can find how long, how far the pool can be spread. This 42, the factor, accounts for the unit conversion. Okay, the unit conversion accounts for the unit conversion, and there are that are necessary to result in pool fire. Now, let us see in this equation what is heat release rate. Heat release rate is given by this equation where m dot is the mass burning rate of fuel and delta Hc is effective heat of combustion of fuel expressed in kilojoules per kg, and K beta is an empirical constant derived based on experimental studies. dP, of course, the diameter of the pool, A is the area of the dike in square meters. Okay. So, I know the heat release rate. In this equation, you can substitute this. Let us see for different fuel what are the different mass burning rate, heat of combination and empirical constants. Right? These are all required to use this equation, right? To use this equation. So, K beta is required here, heat of combustion delta Hc is required here, and Q dot is required here, and so on. So, look at different fuel. Let us pay attention to methanol, gasoline. The mass release rate is known, the heat of combustion is known, and empirical constant K beta is known. If you know these values for any specific fluid or a chemical, I can always find the length of pool fire. First, I can find the heat release rate, I can then compute the length of pool fire from this equation. Now, let us talk about when fire occurs, what is the flame length? Flame length is an indicator of fire intensity. It is the distance measured from the average flame tip to the middle of the flaming zone at the base of fire. Flame height is an average height of flame measured vertically. Average flame height is given by this equation where Q dot is the heat release rate and dP is the diameter of the pool. Flame height is used to represent the distribution of wall heat transfer. Then what is a wall fire? Flame height of a wall fire can be computed as based on this equation. All these are empirical relationships which are derived based on experimental studies. So, we have two examples which I want you to work out. A pool fire is inundated due to fuel leakage, heat release rate is given, diameter of the pool is known, estimate the average flame height and the length of the pool fire. We have equations, you can use them. The second one is a pool fire scenario arises from leak of a vessel. It contains gasoline. For gasoline, you know the constants. About 3 gallons of gasoline spilled over a wall and the area of spread is 1 square meter. A cable tray carrying pipeline and electrical cable is at a height of 2.5 meter above the floor. Now, when this gasoline catches fire, I want you to estimate whether this fire will reach this cable tray. Cable tray is at 2.5 meter above. So, what you should do? You must find the flame height and check whether this height is not more than 2.5 meters. If it exceeds 2.5 meter, then the cable tray will also catch fire. Okay, that is a serious outbreak. Friends, let us come to the summary of this lecture. We understood that fire is a rapid oxidation of material caused during exothermic chemical process. Chemical reaction is a combustion process. It will continue till energy exists. The reaction will keep on going as there is enough heat, fuel and oxygen. This is known as fire triangle. Combustion of hydrocarbon is highly vulnerable. We have learned how to classify fire based on fuel, based on type of fire and so on. Fire is categorized based on fuel, is also based on burning and it is also based on the process as pool fire, jet fire, fireball, flash fire. We also learned about pool fire in detail in this lecture. So, friends, I hope you understood the sequel lecture on fire chemistry or fire scenario and structures. We will learn more about the rest of this in the next lectures onwards. Thank you very much. Namaste.